Hello everyone! Welcome to today's video presentation. Today, we will be doing our laboratory exercise 6 on interfacing a 4x4 keypad with an Arduino Uno board. The objectives of this laboratory are to introduce you the Arduino Uno hardware, the Arduino software, and to guide you through writing, compiling, and downloading, and testing programs to control a 4x4 keypad using digital's input in the Arduino Uno. Additionally, we will explore interfacing various devices such as the LEDs, switches, piezo buzzers, and of course, the keypad itself. But before that, here's are the materials that we will be using for this laboratory exercise. A breadboard with an Arduino Uno board adapter, 4x4 keypad, 220 ohms resistors, LEDs, and piezo buzzers. For a brief introduction, a keypad is a set of buttons arranged in a block or pad which bear digits, symbols, or alphabetical letters. Pads mostly containing numbers are called a numeric keypad. The 4x4 matrix keypad usually is used as input in a project. It has 16 keys in total, which means the same input values. It is ultra-thin, easy to interface with any microcontroller, and has an adhesive backing for easy mounting for a variety of applications. For its features, it has ultra-thin design, adhesive backing for easy mounting, excellent price or performance ratio, and easy interface with any microcontroller. For the specification, the keypad can handle a maximum voltage of 24 volts DC and a current of up to 30 milliamperes. The keypad provides an 8-pin interface for connecting to a microcontroller or another device. This interface is used to read the key presses from the 4x4 matrix layout. The keypad can operate within a temperature range of 32 to 122 degrees Fahrenheit or to 0 to 50 degrees Celsius. The physical dimensions of the keypad itself are 2.7 by 3.0 inches or 6.9 by 7.6 centimeters. This size makes it compact and easy to integrate into different projects. The cable attached to the keypad measures 0.78 by 3.5 inches, so this cable provides the necessary connections between the keypad and the microcontroller or the power source. And now, how it works. A matrix keypads use a combination of 4 rows and 4 columns to provide button states to the host device, typically a microcontroller. Underneath each key is a push button with one end connected to one row and the other end connected to one column. In order for the microcontroller to determine which button is pressed, it first needs to pull each of the 4 columns, the pins 1 to 4, either low or high one at a time, and then pull the states of the 4 rows, the pins 5 to 8, depending on the states of the columns. The microcontroller can tell which button is pressed. For example, say your program pulls all 4 columns low and then pulls the second row high. It then reads the input states of each column and reads pin 3 high. This means that a contact has been made between column 2 and row 2, so button 5 has been pressed. The 4x4 keypad is a versatile input device that finds numerous applications in electronics projects. The keypad can be used to enter a password to unlock a door or access control system. In robotics projects, the 4x4 keypad can be used as a control panel to send commands to a robot. Also, keypads are essential components in electronic voting machines. The keypad can be configured to generate an interrupt signal when a key is pressed. Aside from that, keypad can represent a musical note or sound effect. By pressing different keys in sequence, users can create melodies or control sound effects in musical keypad projects. And lastly, the versatility of the 4x4 keypad makes it suitable for a wide range of do-it-yourself or DIY electronic projects. And that's for the introduction. Now, let's proceed to our laboratory exercise. For the procedure number 1, connect the Arduino Uno R3 compatible board to your 4x4 keypad as indicated in the given table and graphics below. Go to your Tinkercad and enter circuit. Search for the components, Arduino Uno board and the 4x4 keypad, and then connect them together. Based on the given table, pin 1 is connected to pin 9, pin 2 is connected to pin 8, pin 3 is connected to pin 7, pin 4 is connected to pin 6, pin 5 is connected to pin 5, pin 6 is connected to pin 4, pin 7 is connected to pin 3, and lastly, the pin 8 is connected to pin 2. To save this program 1, here is the code provided. These lines includes the keypad library. This library is used to interface with matrix keypads. Rows and calls define the number of rows and columns. The hexa keys define the characters mapped to each key, while the row pins and call pins define the Arduino pins to which the rows and columns of the keypads are connected. This line creates an instance custom keypad of the keypad class. This set of functions initializes serial communication with the computer. The loop functions continuously checks for a key press using custom keypad.getKey. The loop functions continuously checks for a key press using the custom keypad.getKey. If a key press is detected, it prints the key character to the serial monitor. As you can see in the serial monitor, if you press 1, 1 will appear on the serial monitor, and so on. Each key press will be detected and printed in real time. By the way, here is the schematic diagram of program number 1. That's it for our program 1, and now let's proceed to our program 2. For our program number 2, create and design a musical joke box. Our objective should be a menu-driven system running on a serial monitor screen using a keypad, comprising 6 preschool rhyme songs. With the use of the switches, the user can select songs to be played by Arduino, provide a running light patterns for each song, and played as accompanied by the song being played. For number 1, Twinkle Twinkle Little Star. 2, Baba Black Sheep. 3, London Bridge is Falling. 4, 5 Little Ducks. 5, If You're Happy and You Know It. And 6, Rain Rain Go Away. Now let's proceed to our Tinkercad. As you can see, the materials that we use are Arduino Uno board, a 4x4 keypad of course, breadboard, LEDs, piezo buzzers, 22 ohms resistors, and wires. Now let's go to the code and see how everything works. Here is the same as what we do in our program number 1. So here we define the pin of the buzzer. Next, we define the pins of the LEDs and of course, the frequencies of the musical notes used in our songs. The code here is for Twinkle Twinkle Little Star. It consists of 2 arrays, the Twinkle Melody and the Twinkle Durations. The Twinkle Melody array contains the sequence of the musical notes represented by their frequencies such as the note C4. So for the song, well, the twinkle durations array specifies the length of each notes in beats. And for the other songs, they also use arrays just like I mentioned. Overall, each song is distinct in terms of its melody and note sequence. Aside from that, each song has its unique melody and rhythm. For example, the Rain Rain Go Away, it has a flowing and melodic pattern, while the Five Little Ducks has a repetitive and playful melody. So using this serial.println, it will display a list of 6 songs in the serial monitor. The comment here suggests that after the choose song function is executed twice, the loop will stop. Well, this code is responsible for handling the selections of the song based on user input from a keypad. If you can see the play melody with lights, it's a switch statement to determine which song to play and calls the functions to play the melody associated with the chosen song. When the user press number 2 in the keypad, the Blah Blah Black Sheep song will play. 3 is for London Bridge is Falling. Number 4 here is for Five Little Ducks. Five is for If You're Happy and You Know It. And lastly is for number 6, Rain Rain Go Away. And if the user presses an invalid key, it prints a message to the serial monitor indicating that the song number is invalid. This function plays a melody specified by the melody array on a buzzer connected to the buzzer pin. The durations of each note is controlled by the note durations array. While this code enhances the play melody with lights functions by incorporating visual feedback through LEDs, it lights up an LED corresponding to the current note being played, delays for a light effect synchronized with the note duration, and then turns off the LED before moving to the next note. Finally, for the running light effect, it produces a visual effect where LEDs connected to the LED pins light up in a sequence, first moving forward and then backward. To see how it works, let's try to start the simulation. As you can see, all of the songs are displayed in the serial monitor, which serve as your guide on what number you will press. Now let's try to press number 1. For number 2, for number 3, for number 4, for number 5, and lastly for number 6. As you can see, here is the running light effect, first moving forward and then backward. Here I will try to press the keypad number 9. It says invalid song number. That was our demonstration using Tinkercad. Now we will proceed to our actual demonstration. By the way, here is the schematic diagram of our program number 2. And now let's proceed to our program number 3, a hexadecimal calculator. For our objectives, create and design a hexadecimal calculator that can perform the following mathematical operations such as addition, subtraction, multiplication, and division. The mathematical expressions formed from typing it via the keypad is being displayed over the serial monitor screen, as well as the output of the said mathematical expression. Now let's go to our Tinkercad. The materials needed are the 4x4 keypad, Arduino Uno board, and wires. Just like what we did to program 1, just connect the keypad and Arduino in respective pins. By the way, here is the schematic diagram of this program. Again, this line allows our program to use the Keypad library in our Arduino sketches. Here is the keypad configurations, same as what I've mentioned earlier. It declares string variable to store the user input. We declare this to store the selected operators such as the addition, subtraction, multiplication, and division. This will track whether the user has selected an operator, while this code is used to track whether the first operand has been entered by the user. This two-line here initializes an unsigned long integer to store first and second operand entered by the user. Again, this is used to initialize serial communication. With this, it will print a message to the serial monitor indicating that it is the start of the calculator program. Also, this serial.println is it will prompt the user to choose an operator. It lists the operators, the plus sign or the addition sign, subtraction sign, multiplication sign, and division signs, and their corresponding input keys such as A, B, C, and D. This code will read a key press from the keypad and stores it in the variable key. For this code, if you press asterisk, it will clear your input. Basically, in other terms, it will reset and a message will appear cleared and you need to choose another operator. We use else if to check if the press key is an operator and ensure that an operator has not been selected yet. Then it will appear what operator you choose and will prompt a message to enter the first command. While here, it checks if the hashtag key is pressed, an operator has been selected, and the first operand has not been entered yet. This calculate functions calls to perform the arithmetic operation based on the previously selected operator. This function simplifies the code by providing a clear check for whether a given character represents an arithmetic operator. The return statement checks whether the input character key matches any of the specified characters like A, B, C, and D, which are used as operators in the calculator. If the key matches any of these characters, the expression evaluates to true, indicating that key is an operator. But if the key does not match any of these characters, the expression evaluates to false, indicating that key is not an operator. We use this to convert operator character like A, B, C, and D into a string representation, like the addition, subtraction, multiplication, and division sign. For the cases A, B, C, and D, for A, the function returns the string to addition sign. For B, the function returns the string to subtraction sign. If C, the function returns the string to multiplication sign. And if D, the function returns the string to division sign. And for the default, if the key does not match any of these cases, A, B, C, and D, the function returns the question mark. It initializes an unsigned long integer result to store the result of the calculation. Here, it will calculate the sum of the operand 1 and 2 and assign it to the result. Then here, it calculates the difference between the operand 1 and 2. While here, it calculates the product of operand 1 and operand 2. In this code, it will check if operand 2 is not 0. If true, it will calculate the integer divisions of operand 1 and 2 and assign it as result. If operand 2 is 0, it prints an error message indicating division by 0 and returns from the functions early using return. For invalid operator, if the operator does not match any of the expected cases like A, B, C, and D, it will print an error message that indicates an invalid operator. Finally, here is for our serial output. So now let's try to simulate this program. To see how it works, let's try to start the simulation. As you can see in serial monitor, so this is the hexadecimal calculator, and the first thing I need to do is to choose operator. A is for addition, B is for subtraction, C is for multiplication, and D is for division. So let's try A. Yan. And then first operand 5, hashtag 5, hashtag. So it says decimal value is 10, hexadecimal value is A. So calculation complete. Let's try another one, letter B. First operand is 8 minus 2. So decimal value is 8, hexadecimal value is 6. Calculation complete. Now let's try letter C. First operand is 6, hashtag 4, hashtag. So, the decimal value is 24 and the hexadecimal value is 18. Okay, let's try division. Letter D. First operand is 8 hashtag 2 hashtag. So, the decimal value is 4. The hexadecimal value is 4 also. Calculation complete. So let's try this D 0 hashtag 0 hashtag. It says error, division by 0. Now I will press any number and then press asterisk to clear my input. Here, as you can see, it's already cleared. That's it for our Tinkercad demonstrations. Now let's see our actual demonstration. That is all for our program number 3, and now let's proceed to our program number 4. For program number 4, we need to design an Arduino circuit for a password-driven piezo buzzer. Our objective is the program will ask the user to enter a password. If the password is correct, it will buzz off the correct musical tone, and a running LED will light from left towards right. Otherwise, it will display the incorrect running LED's pattern together with a sound off from the buzzer, and ask again the user to enter the correct password. Provide 3 trials for entering of the correct password. At the last attempt, if still the password is incorrect, Arduino will disable the keypad. And now, let's proceed to our Tinkercad. The materials that we use are the 4x4 keypad, the Arduino Uno board, the breadboard, LEDs, piezo buzzers, resistors, and of course, the wires. Here is the schematic diagram of our program number 4. Here, we define a constant string and it initializes with the value of 082302, which is the correct password. And this line is used to track the number of attempts to input the password. While this represents the maximum number of attempts to input the password, so the maximum number of trials is 3. In this line, we define an array of constant integers which is LED pins, and it initializes the pins number A0, A1, A2, A3, A4, and A5. In this code, where the buzzer is connected, which is in pin number 10. We define here 2 constants, the correct and incorrect tone. The value represents the frequencies in hertz for the tone emitted by the buzzer. And based on the value we set, correct tone has higher pitch hertz than incorrect tone with a value of 500 hertz. This for loop is to set up each LED pin as an output. While this line will send the message enter password in the serial monitor. In the loop function, it checks if the user has exceeded the allowed number of the password attempts. If so, it will print a message and disables further input by entering an infinite loop. If the user has not exceeded the trials, it reads the user's password input via the serial monitor. It verifies against the correct password and responds accordingly. All of this code handles input from a keypad where users can enter a password. If the hashtag key is pressed, it checks the entered password against the correct password. It calling appropriate functions for correct or incorrect passwords and increments the trial count. If the asterisk key is pressed, it resets the input. For any other key, it appends the key to the current password and displays the input. The trial count resets on correct entry and increments on each password submission. Here, it will executed when the user enters the correct password. It begins by printing correct password to the serial monitor. For the tone, it will play in 1000 Hz for 500 milliseconds. Then for the LED, the loop iterates through the LED pins array, turning each LED pin on or high for 100 milliseconds and then off. Lastly is for the incorrect password. This function is designed to provide feedback when an incorrect password is entered. It starts by printing incorrect password to the serial monitor. Next, it emits a 500 Hz tone on the buzzer for 500 milliseconds using the tone function. And for the LED, it is same as I mentioned in the correct password execution. And now, to see how it works, let's now start the simulation. In the serial monitor, it asks to enter the password. Remember, the correct password is 082302. I will enter the correct password thrice. And now, I will enter the incorrect password. Since I reached the maximum attempts, the keypad is now disabled. It will no longer accept any entry of passwords. That's it for our Tinkercad demonstration, and now here is our actual demonstration. That's conclude our laboratory exercise number 6, interfacing the keypad with Arduino Uno. Thank you for watching!